Hello and welcome back to the development of the Feersum scheme compiler. Today's episode is going to be YouTube only because I'm having internet problems and I can't stream. So we'll start as we have in the past by reviewing what we did in the last installment. So here we go. In the last stream we concentrated on this bound formal structure. So we introduced a new type, bound formals, which is either a simple identifier, a list, or a dotted list pattern. And in the binder, we used bind formals and bind formals list to inspect the formal parameters to a lambda definition. And if it was a list of IDs or a list of IDs with a dot, we would use a list pattern and introduce a local definition in the lambdas context for every one of those identifiers. So now we've got formal parameters sorted. Today's episode we'll just quickly have a look at doing some compilation work. So in the compiler, when we emit our lambda definition, we do it by calling emit named lambda, which will emit the body of the method. And then we just have this to do here, which is stubbed out, where we do context.il.emit opcodes.load null. And this means that if I run the compiler and try and enter a lambda, I will just end up with null back instead of any kind of representation of that could be called. So if I do lambda, which takes no parameters and returns 123, I will remove that breakpoint and see the result. The result is just the empty list. And that's because we're loading null instead of anything that actually represents the state of the lambda. So if we go back to the compiler, we can do something about this. So in this case, method is the definition or method definition. So this is a monosyllable method definition. So what we want to do is find some way of representing that can be passed around as objects, because in our runtime everything is passed around as objects. So doubles are boxed, and in this case we're going to use system.func to hold references to our methods. So we start off by emitting that method. So the opcodes.load function will load that function, give it the method. It's not happy about that, so we'll just upcast that to a method reference, because method definitions are also references to those methods. And then a null and a function are all we need to create an instance of a system.func. At the moment we're not doing anything special to handle parameters, and that will be a job for another day. So we will just do func obj. So we start off with, we need to import a reference to the constructor of system.func. System.func of type object. So we will do that by getting the assemblies main module and import referencing the system.func. We can just do type off for this. System.func obj get constructor. And we want to get the constructor which takes system.object, which is type of obj, which we are using. That's what our load null reference is here. And this is the state that a system func will hold on to. And the second one is what's called a native int, which is system.int pointer. And they want to be an array. And that's not how you do an array in F#. We need to use the semicolon. I might extract the constructor's parameters out into a local. Now we have a reference to func object. We just need to do context.il emit opcos.new object func object creator. So we will load all the parameters that are required for the constructor that we're going to call, and call new object, and that will create a new instance of that object using the constructor that we've given it. So with any luck, we should now be able to run our program and see something other than null when we define a lambda. Now see a system.func. If we have a look at what other scheme compilers produce when you try and reference a func, it will probably have a hash and a variety of other things in it to make it something that will pass as a pass as valid scheme as well. The idea being that what's called the external representation should be something that you can pass back into a value in scheme. So we have this external wrapper, which is used by the CLI to print out the values when we do when the interpreter gets a value. At the moment, we're using sprintf if we get anything that isn't recognized as either a boolean or a double. So I think in here we want to say if it is a system.func obj, then we will return something that looks a little bit like this. So this will look a little bit more like other schemes representations of functions. So if we run that again, we should be able to define a lambda and see something more interesting when we actually use it. That's a bit nicer. So I think that's enough to commit. I'm gonna say that this introduces create func instant when lambdas are referenced So these things aren't yet callable, but we do actually have some representation of them on the stack when we reference a lambda. Right, well, I think that is just about it for today. So thanks, and I know this is a short video, but it's just to put something out. I was hoping to be able to stream today, but unfortunately the weather and internet has not really made that possible. But thanks anyway for watching, and I will see you next time on Twitch.